We shall now discuss, as per our syllabus, the zero and first order reactions in detail. So first we have zero order reactions. General rate law for a zero order reaction can be written as rate equal to K into concentration raised to power 0. Therefore this is constant. Let A changing into products is a zero order reaction. Then concentrations of A at T equal to 0, let it be C0. At time T, let it be Ct. Therefore rate, which is equal to K, is equal to C0 minus Ct divided by T, or Kt equal to C0 minus Ct, or Ct equal to C0 minus Kt, where K is as usual the specific reaction rate for a zero order reaction here. Characteristics of a zero order reaction. Number 1. Since rate is equal to K, hence rate of reaction remains constant throughout the course of reaction. The second characteristic is the unit of K will be same as that of rate, that is mole, liter inverse, second inverse, or in general mole, liter inverse, time inverse. Third, the time required to complete a definite fraction of reaction is proportional to initial concentration C0. Therefore, the half change period T half for a zero order reaction will be given by, since Ct equal to C0 minus Kt, put T half for T and C0 by 2 for Ct. Therefore, C0 by 2 equal to C0 minus K into T half, or T half is equal to C0 upon 2K. Therefore, T half is proportional to C0. Similarly, the total time T completion taken for the completion of a zero order reaction will be given by, since Ct equal to C0 minus Kt, put T completion for T and Ct equal to 0 at the end of the reaction. Hence, 0 equal to C0 minus K into T completion. Therefore, T completion will be equal to C0 upon K. The fourth characteristic is examples of zero order reactions. A. H2 gas plus Cl2 gas in presence of sunlight absorbing energy H nu to give HCl gas. B. Decomposition of various gases on the surface of a metallic catalyst, for example 2Hi on the surface of gold to give H2 plus I2. 2NH3 on the surface of tungsten or platinum to give N2 plus 3H2. 2PS3 on the surface of molybdenum to give 2P plus 3H2, etc. These reactions usually occur at high pressure. Under this condition, the metal surface gets saturated with gas molecules. So a further change in reaction conditions is unable to alter the amount of reactant gas on the surface of catalyst, making rate of reaction independent of concentration. Let us solve the following numerical question regarding a zero order reaction. The question is, the decomposition of ammonia gas on the surface of tungsten follows zero order kinetics. The half change period for an initial pressure of 70 torr of ammonia is found to be 5 minutes. If the initial pressure be 0.25 atmosphere, what will be the new half change period in minutes, and also calculate the total pressure in a closed vessel at constant temperature after 3 minutes time in the latter case. The solution of the question is as follows. The reaction is 2NH3 on the surface of tungsten gives N2 plus 3H2. Since in case of gas, partial pressure is proportional to the concentration, hence we can replace concentration terms by pressure terms in the formula for a zero order reaction, that is Ct equal to C0 minus Kt can be written as Pt equal to P0 minus Kt. Of course, K will now be in terms of pressure into time inverse.